The general idea behind a lot of the work I'm doing is really focusing on precision medicine. So we want to understand how genetic risk factors may be modulated by important biological variables such as sex status or race and ethnicity or ancestry. And so this study really sought to investigate this on a large scale, particularly looking at the APOE genotype, which is a very well-established risk factor for Alzheimer's disease, particularly the APOE4 allele being very much a risk-increasing genetic risk factor and APOE2 being a risk-decreasing risk factor. But there's also a lot of evidence that has been gathered in the past showing that these effects are different depending on sex or race and ethnicity. So we sought to interrogate that in a very, very large scale. So we ended up actually with almost 70,000 individuals, substantially increasing the sample sizes compared to prior work. And some of the very cool things we observe, for instance, is that there's a very specific effect whereby the APOE3/4 heterozygote individuals have a stronger risk in terms for females, and particularly at the ages of 60 to 7. And what was nice is that we didn't just observe this in non-Hispanic white individuals, which is the largest population generally studied, but we also observed this in a good sample size individuals of non-Hispanic Black and Hispanic origin. And so in that way I think that's a very nice addition to show that something like this, APOE3/4, being a risk factor for Alzheimer's disease specific in women, that effect is consistent across different populations. So that's very important when we think about designing research studies centered around APOE, and when we think about clinical trial design in terms of how we recruit people and which individuals are at more risk or less risk for Alzheimer's disease. So I think this is a very important finding. And similarly, we observed that the APOE genotypes, APOE4 and APOE2, have actually the least pronounced effect in Hispanic individuals from all populations that we studied. So also this is generating a lot of thoughts on how we investigate that further with downstream research and how we make considerations again for clinical trial design and for dealing with diverse populations within the broader AD research community. So some of the work we're interested in is we also study the effect of ancestry, but there's two ways you can study this. So one is where we look across the entire genome, what is your global ancestry? And another way is where we can look specifically on the APOE gene or the APOE locus, the local ancestry. And so that tells us something about haplotype structures there that may explain something about a particular other risk variant in that locus being present in a particular ancestry background that could modulate, for instance, expression levels of APOE, and in that way explain differences across populations. And so something we're really interested in is understanding what's going on in the Hispanic individuals. Do they have particular ancestry haplotypes on APOE that explain these differences, and particularly the Amerindian ancestry, which is more prominently present in Hispanic individuals than in any of the other in any of the other race and ethnicity groups that we studied. So that's definitely one line of research we want to follow up on. Yeah, and I'm also very excited to announce that actually on October 1st I'll be starting my own lab in the Neurogenomics and Informatics Center in Washington University in St. Louis. And so essentially I'm really going to continuing there my line of research that focuses on personalized genetic medicine, where we look at genetic data, multi-omics data, and with a particular focus on understanding sex differences and understanding ancestry differences. And so I'm very excited about that, and I'm hoping to collaborate with many people and recruit many people to do really exciting research in this field.